Hello students, I am Professor Sudhir Kumar Tewatia. I am BTech from IIT Delhi, MTech from IIT Roorkee, and been Vice Chancellor, Director, Dean, Professor in India and abroad of various universities. So today we are discussing a topic like motion and collision in vertical straight line. So this is interesting numerical. As we started the series number Pakke, and in my last lecture I told that all concepts of this type, like whatever twist can be there in the numerical, I have explained last time, and here is the example of that numerical. If one does this numerical, that means all concepts of this chapter, motion and collision in vertical line, will be clear, and student can attempt any numerical for NEET, for IITG mains, for IITG advance, and even toppers of IITG advance. I think first 100, 200 or 300, they go to IISc Bangalore, they get almost complete marks in PCM. So that is the highest institute for research and even for JEE toppers, IISc Bangalore. So let us start the numerical. The first one, I read the numerical. A toy rocket mass without fuel is 0.02 kg, fired upwards from a 15-meter high cliff with an acceleration of 10 meter per second square upwards, and that finishes its fuel after 3 seconds. So if you read up to just this point, and after that the question may be asked that after what time it will fall on the ground. So this question came in NEET exam, only this much. So for NEET exam it's the easiest. Next we go, after 2 seconds a bullet of mass 0.02 kg and velocity 110 meter per second is fired from the ground to hit the rocket. Find the time, velocity and distance traveled in the last second before the rocket hits the ground in the following cases. Even up to this point, this is IITG main question, that this will collide, bullet will collide with the rocket, and we have to find their velocity after collision and their time of fall to the ground. But again, if these things are added more, that becomes the question for JEE advance. So up to this point 3, the collision is perfectly inelastic. What percentage is the kinetic energy lost? Up to case 1, it is JEE mains question. 2 is also collision is perfectly elastic, that means no energy loss. Up to this point also it is JEE main question, and then 20% kinetic energy is lost in collision and maximum percent loss possible in collision. So this difficulty level keeps increasing in case 3 and 4, and 4 is general, like up to the level of 12 student, we can say a bit research type of question. Not much, not detailed, just apply the common sense. That is asked maximum percent loss possible in collision, whether elastic or inelastic, whatever. So what can be the maximum percentage? So let's start the numerical. Earlier we have explained this. This is previously, and it has been discussed in detail. So I will not spend much time in the initial portion. So step 1, find the height and velocity of the rocket at the time of firing of the bullet, and proceed as in the last videos. You have to see our last videos to understand this question properly. So height achieved by rocket, it is obvious. Rocket is fired from here, 15-meter height. Then up to 3 seconds, it accelerates up to this point. Then when fuel finishes, for another 2 seconds, it keeps rising upward. when bullet is fired after 5 seconds. When bullet comes, takes time to hit it, another 1 second, that we will calculate, it further rises. So we have to add these distances, h 15 meter plus this distance in 3 seconds, distance in 2 seconds. We have to calculate first when the bullet is fired. So height achieved by rocket in first 3 seconds, simple, ut plus half at square, u is 0 because rocket starts from 0. Then acceleration of rocket A is 10 meter per second square upwards. So we will take this positive, not negative like G. Acceleration is upward due to fuel. And 3 seconds, so it is 45 meter. So this distance is 45 meter. Then velocity after 3 seconds, v is equal to u plus at. So 0 plus 10 into 3. So that is 30 meter per second. Here velocity is 30 meter per second. Distance is 45. And then u1 here given 110 per meter square. Here this u1. This is velocity of the bullet. So after 5 seconds, in another 2 seconds. After 5 seconds means after another 2 seconds. Like from here add 2 more seconds. So height achieved by rocket in 2 seconds more is s is equal to ut plus half at square. So here u was 30 meter per second upward, time 2 minus half. Now G will act after the fuel is finishes, after the fuel finished from the rocket. So G will act and G will be minus 10 meter per second square downwards. So it will be negative. In another 2 seconds, rocket rises further by 40 meter. And velocity after another 2 seconds, v is equal to u plus at. So 30 minus 10 into 2, that means 10 meter per second. So now the initial height difference between bullet and rocket, 15 meter plus 45 plus 40 is equal to 100 meter. Then relative velocity, velocity of bullet minus velocity of rocket, u1 minus u2, 110 minus 10, 100 meter per second. We have already solved this question in detail in our last videos. So nothing new here. So S1 is equal to ut plus half at square is equal to 10 into 1 minus half into 10 into 1 square, 5 meter. That means an S2 110, this is height gained by the bullet when it collides, 105 meter, this is 5 meter. We can understand it from here. This is 5 meter, this is 105 meter. So this first velocities before collision, u1 is equal to u plus at, because time of collision is 1 second, initial velocity 110, so 110 minus gt, that is 100 meter per second. u2 is u plus at, that means u minus gt, this is 10 minus 10 into 1, 0 meter per second. So before the collision, velocity of the bullet is 100 meter per second and velocity of rocket is 0 meter per second. Now we come to the case 1. This case 1, collision is perfectly elastic. What is percent kinetic energy lost? So this is similar to the previous question as we solved. Bullet gets embedded in the rocket. So here conservation of momentum, this law m1 u1 plus m2 u2 is equal to m1 plus m2 into v. V is the velocity of the combined mass. So that comes to be solving this 50 meter per second, because both are of equal weight. So adding momentum and combined velocity will be reduced to half of 100 is 50. Kinetic energy after collision, half m1 plus m2 combined mass plus v square is 50, that is 50 joules. Kinetic energy before collision, one is having half m1 u1 square plus half m2 u2 square, so 1.02 100 square, that is bullet kinetic energy. This kinetic energy before collision of the rocket was 0 because it was at rest. The initial velocity was 0. So 100 joules. So initial kinetic energy 100 joules, final kinetic energy 50 joules. So loss in kinetic energy is 50 joules. That means 50%. So when velocity and time, when the rocket reaches the ground, we come to the next point. So initial velocity of the rocket at 105 meter, 50 meter per second. Final velocity we have to calculate. S is equal to S2 is equal to minus 105 meter. Why I am taking minus 105 meter? Because this distance S2 is 105 meter. From here to reach here, that means downwards. So when distance is downwards, we take the negative sign, minus 105. And G is equal to minus 10 meter per second square. It's incorrect, please correct it. G is minus 10 meter per second square. So V square is equal to U square plus 2AS is equal to 50 square plus 2 into G is minus 10 A. S is minus 105, minus minus plus. So 2500 plus 2100, 4600. So square of this is this. So V is plus minus 67.82 because V square is equal to this. Now we have to choose whether we have to choose plus or minus. So this is by common sense. Like velocity is downwards, so we will take minus sign. Velocity is minus 67.8 meter per second. As the velocity is downward, we take the negative sign. So this V is equal to U plus 80 is equal to 67.82. So minus 67.82 is equal to 50 plus minus 10 into t. We are calculating using this equation time. How much time it will take to reach the ground rocket from that height. So that from the first equation it comes 11.78 second. Now distance traveled in last 1 second before striking the ground, that is between 10.78 second and 11.78 second. Last second is just 1 second before that distance traveled and to that time. So in between this 1 second, that is SNth. This distance is numerically equal to the velocity at average time because G is constantly increasing with the uniform acceleration. Average time is 10.78 plus 11.78 by 2 or 11.28, or we can write 11.78 minus 0.5. That means half second. So as is evident from equation or formula for SNth second. I will like to clear this point, and it is another concept to be clear to the students. So far, almost in every book or everywhere you must have seen, or I doubt that whether you have seen it earlier. The SNth second usually is asked in the whole number. It's a natural number. 9 second, 10 second, third second, like this. But this is fraction of the second. But it holds good for this also. So that's why we have to remember the formula in this way. SNth is equal to U plus A into N minus 0.5. I have explained earlier. So 50 plus minus 10, that is minus G. 11.78 minus 0.5, 62.8 meter. So as the another second is 11.78 or N is equal to 11.78. So velocity traveled in the last second before hitting the ground by the rocket, distance traveled is 62.8 meter. I would like to make another concept clear for the students here, that we are asked the distance here SNth in 1 second, but units are of velocity. Here also it should be meter per second in last. U is unit of velocity, A into time, again the velocity, Why it is the unit of velocity? Otherwise, it's a distance. Because it is per second. Per second means distance per second. Last second, 1 second. So that's why units are of velocity. Though it's a distance, but distance in 1 second. Now we come to the case 2. There is no loss of kinetic energy in elastic collision. So we equate the conservation of momentum law as earlier, and we get this equation V1 plus V2 is equal to 100. Earlier also it was. Conservation of momentum law holds good everywhere, whether the collision is elastic, inelastic, or in between these two. It holds good everywhere. Then conservation of energy, half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square, because m1 is equal to m2, both are equal, so m and half they all get outside, and this equation reduces to u1 square plus u2 square is equal to v1 square plus v2 square. Then u1 is 100, u2 is 0, so v1 square plus v2 square is equal to 100 square, and this is v1 plus v2 is equal to 100. Now solving this equation, making quadratic or by any other method, you will find this v2 comes to be 100 meter per second and v1 is 0 meter per second. It is interesting conclusion from this numerical that when the bullet strikes the rocket, both are of the same mass. So bullet transfers entire velocity to the rocket, comes at rest. Rocket was at 0 velocity. Now at its strikes after the collision, bullet will be at 0 velocity and rocket will take the velocity of the bullet, 100 meter per second. Now case 3, when 20% kinetic energy is lost, that means 80% kinetic energy remains after collision. So equation 2 reduces to here this equation or this equation. So earlier this 0.80% of initial kinetic energy is equated to final kinetic energy, and again it is solved for this v1 v2 and we get this answer that v1 is equal to v2 is equal to 88.73 meter per second and v1 is 11.27 meter per second. Now we come to the last case, case 4. It is bit research oriented. As you know, IISc Bangalore is number 1 in India in research. IITs are no match for IISc Bangalore for research. And now even among the JEE toppers, they are also going to IISc Bangalore. Those who are interested more in research, they go to IISc Bangalore, and the percentage of the marks who are where the cutoff comes, at least for the general category, I think they are getting complete marks in JEE Advance. Only 4 or 5 marks are deducted from the total PCM. So it is very highly reputed, not only in India but in the world. Some of its professors got Nobel Prize. You can see more on the Google. So anyway, just to inculcate the spirit of research in the students, I have further modified this question like this. That question comes, case 4, if mu times of initial kinetic energy is lost after collision, find the maximum value of mu, whether elastic, inelastic or combination of both. So what can be the maximum value? How to get it? So usually what students do, they make some equation for mu and they go for differentiation, maximization or minimization. But without that, we can do it by simple inference of the equation that we solved here. If you look here, this V2 we are calculating, this is square root, this quantity. And if the square root is negative, that comes imaginary. That means that V2 is not possible. So this quantity should be positive. That means this should be greater than 0. So if we put mu here instead of we put earlier 0.8, so we solve this equation putting like 1 minus mu, and that this is with you and you do it yourself. you see it comes V2 is equal to 100 into 1 plus minus 1 minus 2 mu under the square root raised to the power 0.5. So under the square root quantity cannot be negative, maximum it can be 0. So 1 minus 2 mu is 0. That means mu is equal to 1 by 2. That means 0.5. So maximum kinetic energy lost is 50% in this case. That is when the collision is perfectly inelastic, as in case 1. So in my next video, I will elaborate more on the differences between the numerical for NEET exam, for IIT mains exam, for IIT JEE advanced, and what they try to see in IISc Bangalore, because I combine in myself my education from all these institutions. So I will talk in detail that if they give such numerical, why is it so? In brief, I can tell even now, just in 2 sentences. Suppose students is trying wants to become a doctor. A doctor doesn't have much time. His concept should be clear with the basic knowledge, and with the limit of time he has to treat the patient. But an engineer for IIT mains, he has some time. Difficulty level is more as compared to IIT for IIT mains as compared to NEET, because he has some difficulty. He is constructing some, say, Burj Khalifa, some tower. If he spends another 2-3 months or 6 months, even then no problem, or some problem, but still it's allowed. Further comes IIT advanced, and then research. Research doesn't have such criteria like limit of time, like immediately we have to do this research. It may take, if the idea clicks, it may be like soon, or some scientists spend their life and even then they are not able to search something. But anyway, that's a different issue. That's all for today. Thank you.